Okay, this is from section 5.1. It gives us the polynomial function negative 9x squared times the quantity x squared minus 7. And for this function, we're going to have to go through all these parts here to kind of get a good idea of the graph. This problem doesn't actually ask us to graph it, but just for fun, we're going to kind of imagine what the graph might look like over here. So part A says find the zeros. So since it's already in factored form, we just set each factor equal to 0. So the first factor is negative 9x squared equals 0. If we solve that for x, we're going to get x is equal to 0. It's going to have a multiplicity 2. Now, part 2 is this factor here, x squared minus 7. We set that equal to 0, we're going to get two answers. X could either equal square root of 7 with multiplicity 1, or x could equal negative square root of 7 with multiplicity 1. So then to know if it's going to touch or cross at those points, it's going to touch at 0 because it has an even multiplicity. So I already plotted that dot here. It's going to cross at square root of 7 and negative square root of 7. So square root of 7 is about 2.6, so it'd be about right here, and negative square root of 7 would be about right here. Let's look at the behavior near each x-intercept. So we didn't get a chance to go through this in class. What we're going to do is we're going to write this in totally factored form so that we have the negative 9x squared, and then each one of these I wrote it in a little bit of a different factored form than the original because this is the factored form where we can see what our zeros are. So if we have it in factored form, if we want to know what's happening near this 0, x equals 0, we're going to let each factor that has the x in it represent this 0 except for the one that we got it from. So we got this x equals 0 from this factor here, so we're not going to let that one equal 0, otherwise the whole thing would go to 0. But each of the other ones we're going to let our x equal 0, and we're going to solve this out to find out what we get. So once we solve this out, we're going to get 63x squared, and you can pause it if you need to look at my work here. 63x squared, that's what the function's going to look like near x equals 0. Now to each of these other ones, when x equals square root of 7, that's at this point up here, we want to know what the function is going to look like. Well, since x equals square root of 7 is going to give us a 0, we're going to put square root of 7 in all the factored spots except for the place where we got it from. So because square root of 7, if we put square root of 7 in here, it would turn the whole thing into 0. We're not going to put it into this x spot, but we are going to put it into each of the other spots. So we're going to put it here and we're going to put it here. And we're going to simplify this as far as it will go. And once we simplify it, we actually are going to get this thing here, negative 333.36 times x minus the square root of 7. Basically, that's what the function is going to look like near this point here at square root of 7. Now, near the negative square root of 7, we're going to do the same thing, find out which factor this negative square root of 7 came from, and it came from this one here, the x plus square root of 7, because if we plugged in a negative square root of 7 into this x spot, again, we would get a 0 here, which would turn the whole thing to 0. So we don't want to put it in there, but we are going to put it in the other two x spots of the factored form. Once we do that and we solve out all that work here, remember when we add a negative square root of 7 and a negative square root of 7, we get negative 2 square root of 7, and then we times those together, we're going to get this here, 333, positive this time, 333.36 times x plus square root of 7. So that is the behavior near each x-intercept. That kind of just gives us a better idea of what's happening. If we were to graph these, it would look similar to our graph near those x-intercepts. Part D says the maximum number of turning points, so we just look at what is our degree of our polynomial. Our degree is degree 4, so we take 1 away from that, so there's at most 3 turning points. And the end behavior is going to be similar to our leading coefficient, which is negative 9, and our highest power. So x to the 4th is our highest power, so it's going to resemble that. So let's see, since it's going to resemble this negative 9x to the 4th, we know it's an even power and it's negative, so our end behavior should both be going down at the ends. It's going to bounce off of that 0 and cross through everything else. So maybe a good little picture of our graph would look somewhat like that. Again, if we wanted to know exactly what's happening inside here and here, we could pick more values for x to plug into the function to find out our y values, because it could go further up or further down, but this is kind of just a rough sketch of our polynomial.